In this video, we are going to very quickly review one of the topics we talked about in the Introduction to Digital Technology course, which is binary math. And we're not going to spend as much time on it this time, but I want to go over it just to make sure that if you haven't seen it, it's a little bit of a primer into binary math. And if you have seen it, it's a quick review to make sure that you're up on the step. The concept of binary math is what we call our first abstraction. We use ones and zeros to represent information in a computer. And binary math, since obviously we want our computers to be able to do math for us, we need to be able to represent numbers in a computer. And in this course, we're going to talk about that significantly. So, to review binary math, let's start with binary addition, which is base 2, so we have two options. We have a 0 or a 1. That's what a switch is. It's either off or it's on. Okay? So when we add, if we get a value of 2, we must carry it to the next place. And if you recall, that means 0 plus 0 is obviously 0. 0 plus 1 is 1. If we get the bits in the other position, it doesn't matter. 1 plus 0 is also 1. But if we get 1 plus 1, it's a remainder of 0 and a carry to the next place, because we have created a power of 2 that we must carry. And when we do the carry, we are carrying a single power of 2, so that is a 1 that we carry. Okay? So let's look at some examples. 0 plus 1 is 1. This should not be shocking at all. 1 plus 0 is 1. But in the case of 1 plus 1, again, we have a 0 and we carry the 1, which in this case would then drop down. So 1, 0 in binary is the number 2 in base 10. So let's do a little bit of a harder one. 1, 1 binary, notice I didn't say 11. So 1, 1 plus 1, 1. The 1 and the 1 gives me a 0 and I carry it. Then I get a 3. Well, if I can only do 0, 1, I can't even do a 2. How do I do a 3? That's a remainder of 1, and I carry 1, which then comes down. So 1, 1 plus 1, 1 binary is 1, 1, 0, which is 4 plus 2, which is 6. And 1, 1 binary is 3, so 3 plus 3 does in fact equal 6. So we know we got that right. All right. One of the things I always recommend is that you draw the base 10 positioning for each bit in a byte, if that helps you clarify. So let's do some math here. We're going to add 12 and 12, and we should get 24. Now 24 would be what? 16 and 8. Okay? So we should see these middle two bits set and everything else become a 0. But let's go through it and make sure we get it right. So yes, we've got 12 plus 12. So 0 plus 0 is a 0, another 0. That's a 0, and we're going to carry the 1. That's that 3 thing again. So that's a remainder of 1, and we're going to carry the 1. Bring that down, and then the rest drop. So sure enough, 16 and 8 is in fact 24. We got that one correct. So as you can see, binary addition is fairly straightforward. Okay? Now, let's do another one. So here we go. That's a little bit of a tougher number. This is actually 95 and 158. Okay? Don't let the fact that they're larger numbers mess you up. Okay? Don't let it scare you. It's just more of the same. Okay? We're not changing the rules at all. It's the same process we just did. So 1 and 0 is a 1. Then we're going to 0 remainder and carry it. We're going to have a 1 remainder and carry it. 1 remainder and carry it. 1 remainder, carry it. That's going to come down. Then the 1 and the 1 are going to come down. And we're going to get 253. Now we know that's 253 because if all the bits are set, it's 255. If you add up all these numbers, you get 255. And only the 2-bit is not set. So, 255 minus 2 is 253. Another easy way to cross-check yourself. Okay? So in the next one, we're going to begin to talk about how to subtract, because the little secret is computers can't subtract. What we do is we add the 2's complement to the minuend. So we're going to talk about that in the next video and begin to understand subtraction. See you on the other side.